Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at IP routing table. We'll be discussing route sources, route table principles, table entries, directly connected networks, static routes in the IP routing table, dynamic routing protocols in the IP routing table, default route, structure of an IPv4 routing table, structure of an IPv6 routing table, and then finally, we're going to look at administrative distance. This episode is part of my series on switching, routing, and wireless essentials for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. As we look at our IP routing table, we're going to learn these routes from different sources. The routing table, it lists out all the routes it knows of, whether it's directly connected, whether they're remote networks. It's going to list out every network I know how to get to. These entries include the prefixes and the prefix length, the network portion and how long that network portion is for IP version 4 addresses and IP version 6 addresses. Now, the source of that information, it comes from those directly connected networks. It comes from any static networks you as the administrator set up and any dynamic routing protocols you're running. It's going to learn all this information, is going to make all those entries based upon that information. As you look at the routing table, it's going to tell you the source by a code. And here are four of the ones that you're probably going to see quite a lot of. The first one is an L, capital letter L. That is the address that's assigned to that interface. That's that local address assigned to that interface. A C, by that routing entry, says it's a directly connected network. Now, it's not a D, but it's a C. It's C for connected network. An S identifies it as a static route. That static route is the one you sat down, you typed in as the administrator. You want that router to use that one. O identifies it as a dynamically learned network, specifically learned through a protocol called OSPF. That's where the O comes from. It's OSPF. So L is that local link address. C is for that connected address. S is for the static route or static network. And O is for an OSPF dynamically learned network. And if there's an asterisk in that routing entry, in that routing table, that route is a candidate for the default route. There are three routing table principles that the router goes through. First one is every router makes decisions alone. It looks at its own routing table. It finds the best route and sends it out. It doesn't consult anybody. The consultation happens in building that routing table. Once that routing table is built and it gets a packet in, it makes its own decision. It doesn't talk to anybody else. So that router makes its own decision based upon the routing table. The routing table is that conversation that happens between all the devices out there, all the routers. But once it gets that, it makes its own decision. The second one is the information in that routing table on one router doesn't match the routing table on another router because there's differences in directly connected and remote networks. There's differences in maybe the connections between those and which is the best route to get there. And so there won't be two identical routing tables if you compare them from the device to device. There's going to be differences in that. And finally, that routing information about a path, it doesn't provide return information. I will get that information to the destination. I don't care if that information comes back or not. That's what the router says. I will provide information to get it to its destination. I'm not going to provide any information to get it back to me. Now, why is that? Because the path going there may not be the best path coming back. Something may change. There may be additional congestion on the network. A link may go down or a new link may come up, and there may be a better route that once it gets there to make that return trip. when we look at a routing table, we're going to see all sorts of entries for the different networks it knows how to get to. Each one of these entries follow a basic layout. Between IP version 6 and IP version 4, that layout is pretty similar between that. First thing you're going to have here, and right here is an example of a routing entry from an IP version 4 network. We have an version or an entry from an IP version 6 routing. We can see up here that first field right here is what we call the route source. How did we learn about this? We have an O here. That O stands for, we learned it from OSPF. OSPF works in version 4 and in version 6. So we can set up OSPF there. The second field is that destination network. That is that remote network. I know the name of it. I know that network address of it. That network address is right here, that destination address. In the IP version 4, it's 10.0.4.1/24. IP version 6 down here, 2001 DB8 ACAD:4:/64. It's that network address of that FAR network that I know about. Then 3 and 4 are the administrative distance and the metric. Administrative distance is what we call the trustworthiness. We'll cover that in a second here, and then the metric, the value of how do we get there. The fifth field here is what we call the next hop. That would be the idea one router has to send it to another router to get it close to its destination. That second router is that IP address there of that next hop. That's that field 5 here in both the IP version 4 and IP version 6 routing table. The sixth field is the route timestamp. That gives us an idea of when did we learn about it? How long ago did we learn about it? Now, some routing protocols use this, some don't. Notice IP version 6 does not have that. And then the last one is, seventh field, is that exit interface. On the device we're currently at, to get to our destination network, what interface on this router do I need to go out of? And here on the IP version 4 one, we have to go out serial 0111. IP version 6, it's the same interface. Notice how we can have multiple networks, multiple routes using the same interface. A router needs to have at least one active interface. That active interface has to be configured with an IP address and a subnet max or a prefix length if you're doing IP version 6. It has to have that turned on. That is your directly connected network, or some people call it a directly connected route, where we can have that connection onto the local area network and we deliver that packet right to the destination. Those are directly connected. That directly connected network, that directly connected route, is added right when that interface is configured and activated. It adds that into the routing table automatically, the operating system does. And if you look at the routing table, that's where you have the C for that connected network. It's directly connected to me. Then another thing that gets added in here is that local route. That local route, each directly connected network has a local route. And that gets a little L at the beginning for that local route. Local routes for IP version 4 have a /32, so that prefix is 32. Remember, an IP version 4 address is 32 bits long. Well, if we have a /32, IP version 6 is a /128, only 128 bits in an IP version 6 address. It must match all the bits. Basically, what we're saying here is if we match all of the 32 bits, that is for me. That's for the router that's being processed right there. Let's match all the bits in this IP address, either /32 or /128. If it matches that, it's for me. Because it's for me, I know that I can then process it. Maybe it's some sort of configuration or you're SSHing into the router. And it looks and says, okay, it matches the local route here. It matches all the bits. We're going to process this as it's destined for us. Static routes are a way to send information to a remote network. Static routes are manually configured. You as the administrator have to sit down, program that static route into that router. You define that path between two networking devices. You define a path on how to get from one router to another router. How do I get to that other router? You define that. Basically, out what interface am I going? It's not automatically updated. So if you add in another router in a faster route or a more direct route, it will not update it. You have to go in there as the administrator and update that manually. Any reconfigurations that happen, you have to do that. Now, there's three primary uses for a static route. First one, ease of maintenance in a smaller network. And a lot of times when we say smaller network, and especially ease of maintenance for static routes, I'm thinking 3 routers or less. Even if I had a 3 router system or even a 2 router system, I'd look at a dynamic routing. But you can set it up, you can use that. You got 3 routers, you got 6 networks, you're going to need about 6 network statements, static statements in your routing table. You'll have to manually set those up. You make a change, you're going to have to go back and change all of them. The second use is it's a single default route that represents a path to any network. And if you want to make sure that the traffic gets to a certain network and uses a certain way to get there, you set up a static route to do that. So default routes send traffic to a destination beyond the next router. And if you want to send information and you want to make sure it goes a certain way to destination, you set up the static route and force it out an interface. Now, why would you want to force it out of one interface versus another? Well, sometimes you may have 2 different connections on your router, and say you have 2 internet service providers. One charges you a monthly fee for as much data as you can send, and your backup connection is a temporary on-demand connection that you pay per megabyte per gig you send through there. So you want to force all of your traffic to go through that unmetered monthly billed connection rate. But if that goes down, then you want your other route to kick in. And so you want to force everything through that network, but when that goes down, and you statically program that route goes down, you want it to use the other one. That's just a simple example. And the third use is routes to and from stub networks. What a stub network is a network accessed by a single route. So there's only a single route that points to it, and the router only has one neighbor. And you can kind of think of this as maybe like a branch office or something like that. And that's where you'd want to set up these static routes. Static routes in our routing tables. Here's an entry. Here is how we set up a static route. Notice we are in global configuration mode. Top one here is an IP version 4 one. Bottom one is an IP version 6. We're dealing with the IP suite here. So we start off with IP. We're dealing with the route. So it's IP route. Then we have the remote network address. In this example, PC1 on the left is sending to PC3 on the right. And so our destination network is this 10.0.4.0 network, 10.0.40/24. And that's what goes into this remote IP version 4 network address field. The IP address of the network, once again, remember the network address ends in zeros. It's the network portion and then it ends in zeros. If you put an actual IP address in there, where you actually have a host portion with some information in there, it might throw you an error. Make sure you're using the network address ending in zeros. And then right here, the last part, after you put that, the network, the remote network, you put your how to get there. You put how to get there. In this example, we're using the next hop router. So to get to this network way over on the right side, what R1 is going to do is send it to the IP address on a network I am connected to. So it's connected to this WAN network, but it's the far side IP address. So it's this .2 address right here. And so 10.0.3.2, the IP address is on router 2, but it's still on a network I'm directly connected to. That is my next hop router at this point in time. So we got IP route and then the remote network address. So 10.0.4.0, remember it ends in all zeros. You put in your subnet mask, and then what the next hop router is. The next hop router is the IP address of the interface that's connected to the network that those two routers share. The IP version 6 address functions basically the same way. Once again, remember you put in an IP version 6, because IP just means IP version 4, so IP version 6 route. Then you put the network address of that destination network in there. And so that's right here, 2001 DB8 ACAD :4 : Remember, network addresses end in 0, so there's nothing after the : and then we have our prefix that goes right here for our remote network address. Then you put in the next hop IP address, the IP version 6 address of the next hop. That is on a network that is directly connected to me, so that's this network right here. But you put in the far side IP address. That's 2001 DB8 AC :3 : 2. That is that address right there. And so now I know how to get to this network. I go to this address. Because this address is directly connected, I just send it out and I know how to get there. I hope you're liking this episode on IP routing table. If you have the time, please leave a comment and let me know what you think about the IP routing table. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Dynamic routing protocols, they share information. They share information about the reachability, the status of remote networks. Here in this example, we have R1. What R1 is going to do is I'm going to share information with R2. So I'm going to share it with the other router I'm connected to, all the networks I know about. The networks I know about are my directly connected. I'm going to share all my directly connected. So I have 3 directly connected networks. I have 10.0.1.0, 10.0.2.0, and then I have 10.0.3.0. I'm going to share all 3 of those networks with R2. R2 gets that share in, and then it compares it to the networks that are directly connected to it. It looks and says, okay, 10.0.1.0, that network is a remote network because I have to go through R1 to get there. But I now know how to get there. So for network 1, I have to go to R1 to get there. Then I look and see router 1 shared 10.0.2.0 with me. It's not a directly connected. So to get to network 2, I now have to go through router 2. Router 1 also shared 10.0.3.0 with me, but that's a directly connected network with me. I already know how to get to it because it's directly connected. Once again, it learns directly connected networks as soon as you put that IP address, subnet mask, and activate it. It puts it in the routing table. I know about it, so I don't have to add that in. Same thing happens here with R2. R2 shares the information back to R1. And it adds in to get to the 10.0.4 network. I have to go through R2. To get to the 10.0.5.0 network, I have to go through R2 to get there. In the frame of reference for R1, I have 3 directly connected networks, and I know about 2 remote networks. R2 has 3, well, technically 4 to my ISP, and I know about 2 remotely connected networks. Now, some of you are going to say, well, we have this other network coming off of R2, which is for our internet service provider. Yes, technically R2 would share that with to R1. R1 would learn how to get there. But for our example, this is the ISP, and we handle the ISP a little bit differently. We'll get to that in a second here. When we look at the dynamic routes here in our routing table, notice we do a show IP route. First things we see is the codes here. There's about 5 or 6 lines of codes. They cut out some of them, but the up here typically are the most common ones. Here is our routing entry. So they're showing us 2 routing entries. R1 knows about 10.0.4.0. That was on the other side of R2. So we had to learn about it. That's a remote network. We had to learn through it through this code, which is an O. This code is OSPF, Open Source Protocol First Dynamic Networking Protocol. And so looking at that, we learn how to do that. Then this is the network address we learned about with its subnet mask, administrative distance, which is the trustworthiness, and then the metrics. How do I get there? This is the next hop IP address. How long ago did I learn about it? I learned about it about 24 minutes ago. And to get there, I go out my serial 011 interface. That's what we look like. And to tell it's a dynamic route, once again, we look at the first symbol. If we do a show IP version 6, that's how we get the IP version 6 information. It starts off with that same code at the beginning, OSPF. Then we have our destination network. Notice it ends in a 0 here. There's nothing listed. Ended in a 0. Then we have the IP address of the next hop, which is right here. It's a local link address, FE80. And we go out what interface? Serial 0111. That's how you look at these tables and understand what's happening. The default route is the route the router uses when it doesn't know what to do with it. R2 gets in a piece of information. It looks at its routing table. Do I know how to get to it? It knows about 5, 6 different networks right here. It knows how to get to the 10.0.1. That's a remote network. How to get to the 10.0.2. That's another remote network. We have 3 directly connected networks. 10.0.3, 10.0.4, 10.0.5. Those are 3 directly connected. This network that goes from R2 to the ISP, that's also a directly connected. If it can't match any of those networks, what we do is we set up a default route. This default route, instead of specifying a network, what we do for IP version 4, so IPv4, we set up a 0.0.0.0. These 4 zeros a lot of times are called quad zeros. That way you don't have to say 0.0.0.0. You just say quad zeros. That's what they mean. With a /0, IP version 6 is very similar. Remember, if there's zeros, if they're continuous zeros, we can replace it with a double colon. What we get here is just basically a double colon, right, with a /0. What this means, the quad 0/0, the double colon /0 means that 0 or no bits need to match between that destination IP address and that default route. None of those bits have to match. We're just going to send it. And this gets processed at the end of all the routing entries. So if I don't match any of my routing entries to that, we're going to use this default route and send it on. This default route should point to the next hop IP address. So when router 2 gets this in, it's not in its routing entry, so it's not any of these 10 dot numbers up here. We're going to set a default route that says, okay, now it doesn't match anything in my routing table. I'm going to send it to this IP address down here. When I send it to this IP address, it's now going to be this router's responsibility, because this router is now my internet service provider. They should have all the information on how to get to the destination on the internet. Reason for this is, if you're sending out some information to a server somewhere on the internet, you don't want to keep track of all those routes on the internet. That's a lot of RAM. That's really expensive equipment to keep track of every single route on the internet. You just want to keep track of the routes that you are routing internally on your company. If it's not an internal network, we're going to send it to the default route, which is typically your ISP. Then your internet service provider, they can route it towards the destination. They have the equipment. They did that special cost to get that special equipment to route all internet traffic, to know about all the routes on the internet. You don't want all that responsibility. You just want to know what's going on my network. If it's not on my network, I'm going to send it to my ISP. That's where that default route comes into play. Looking at the structure here of an IP version 4 routing table. As you look at this, a couple things to notice. Cisco in its examples a lot of times puts this output omitted. Up here, it was the codes and several other pieces of information. When we look at this table, we're going to notice we have what we call parent routes and child routes. Parent routes are the traditional Class C addresses. Remember how we have Class A, B, and C, and they're divided between the network portion and the host portion. Class A is a /8, so that first 8 octets, the first 8 bits, that first octet is the network portion of Class A address. Class B is a /16, or the first 2 octets. Class C is the first 3 octets, or the first 24 bits. And that's how the parent addresses are. They break it up on the traditional class addresses. Right here, you can see we got 192.168.1.0/24. That is the traditional breakup of a Class C address. Then we have another parent address down here, 192.168.12/24. The difference right here between the network portion and host portion is there. So this is a different network than this one was here, than the other two that are listed. They are different network portions. Then we group the stuff that's underneath them. These are called the child routes. It's indented a little bit. It has a code at the beginning. That's how you can notice the difference between the parent and the child routes. Directly connected are always child routes, because we are looking at that full /32, because that interface is underneath. It's part of this network. And so we have the C, which is a directly connected network. So that's parent child. Yes, it's repeating itself, but it's part of that network. We have our link local, which is the IP address associated to that interface on this network. And then any routes or any networks we know how to get to that goes out the interface that's associated with this network. We know how to get to the .2 and .3 network, sending out this link local address, which is part of this parent network. And that's how we group this up when we look at it. We can tell that this is a directly connected network by the C right here. So this network is directly connected. It's plugged into an Ethernet or a serial cable. L represents, this is the local address, the local link address of this. This is the IP address of what that wire's connected into on my router. And then these other ones right here, we've learned with a code of S, which is OSPF. We have to go out this interface through this network to get to these networks. And what we can see here is this is the administrative cost. This is the metric. Up here, the other ones is directly connected, is what we're saying. And it follows through like that. Down here for this second parent network, we only have a directly connected and the local address. Third network is the same. For IP version 6, Classful addressing was never part of IP version 6. There is no classful, there is no based upon octets or the hextets or whatever you want to call them, where the colons are. There was no addressing ever based upon that. So all the formatting is the same. Notice that we have directly connected networks all in this line. We have the link locals. We have coming down here, we have networks we learned through OSPF. They're all identified the same way. Looking here, we have our destination network. What's that network address of where we're trying to get to? Then we have our prefix. We have our administrative distance and our metrics. This is the next hop IP address of the router. This is the interface I go out of. Notice it's all the same here. Up here for directly connected, a little bit different, but this is the interface it is, and it says it's directly connected. There is no parent or child with IP version 6. Now, the added administrative distance shows us what's the best path to get there. Best path depends upon the protocols you're using, but with a network in today's world, you're going to have redundancy. You're going to have multiple paths to the destination. It is possible for the same network to have more than one routing source. It's directly connected. We learned about it through a dynamic routing protocol. Maybe you're running a couple different dynamic routing protocols. You should try to avoid running multiple dynamic routing protocols at all costs. But in some instances, you have to run multiple dynamic routing protocols. And they could decide one path is better than another path. Maybe one path is a directly connected between R1 and R3. And another path is going from R1 to R2 to R3. But the connection between R1 and R3, that direct connection, is only 10 megabits per second. Where the connection from R1 to R2 and R2 to R3 is some high-end fiber, 100 gigs per second. And so if you're using one routing protocol, the R1 to R3 is the best route. If you're using a different routing protocol that looks at speed also, R1 to R2 to R3. And so you may have conflicting different ways to get there. And so the router, it needs to know which source to use. I learned about how to get to the destination through a couple different sources. Which one do I use? Which route should I put in my routing table to make it the best way to get there? Now, Cisco uses this administrative distance. Another thing is sort of the trustworthiness of the route. Which way did I learn about this? I trust the most, and there's a rating system. One thing to notice is the lower the administrative distance, the lower that administrative distance number is, the more trustworthy that route is. Here are the standard administrative distances for routers. If we look, it starts off with 0. 0 is the lowest number you can have. You can't have negative numbers here. 0 is the lowest. Those are directly connected. Now, why do we want to trust those above anything else? Because those are directly connected. When you configured the IP address on that, when you activated it, the operating system said, hey, that interface is connected to this network. The operating system is not going to screw that up. So I'm going to trust that above everything else. Then we have the static routes in there. These are the networks you put in manually. You went down there and you typed in IP space route space the address of the FAR network with its prefix or subnet mask, and then what the next hop IP address is. You put that information. You as the administrator, you know better. Maybe there's a reason you want to go over a non-metered connection versus a metered connection. You want to use a certain connection. Maybe you're going to take down one of your connections and you want to make sure all traffic is using the other connection. Whatever the reason is, you statically program that route in there. You as the administrator. I'd like to think I'm smarter than the machines I'm doing, so I trust myself a little bit better than some conversation between two routers that decided that. Then after that, we have a bunch of different routing protocols. We have EIGRP, BGP. We have another version of EIGRP. We have OSPF, ISIS, RIP, and then we have some more routing protocols that are happening. For me, there's a handful of these you should learn. You should learn the directly connected networks. That has an administrative value of 0. You should learn the static route. That has an administrative distance of 1. The next couple you typically don't see unless you're an ISP when you get into this BGP. The next one I would look at is this EIGRP, the internal EIGRP. Most people don't run the external EIGRP anymore, but you should learn this EIGRP. That has a value of 90. OSPF is another protocol a lot of people run on their networks. I would learn that number. And then the last one I would look at is the RIP one in here. I would look at memorizing RIP. These are the 5 I memorize that I seem to use the most. Now, how do you memorize them? Directly connected. You trust that because the operating system set that up. You programmed it. The operating system learned it itself. There's no possible way that could get screwed up. Static route. You as the administrator program that in there. That is the second best way to learn something, besides having the router learn itself. Then we get into routing protocols, and notice we have 3 of them here. We have EIGRP, OSPF, and RIP. 90, 110, 120. For some reason, I've committed those numbers to memory, and how I remember which one is associated there is I look at the E, the O, and the R. Eeyore from Winnie the Pooh. That's how I remember the EIGRP, OSPF, and RIP. Those are the common ones I run into. This is what I see most of the time in use in industry are these protocols when we're looking at our administrative distances. It was my pleasure to provide you with this wonderful episode on IP routing table. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. Thank you so much for watching this episode on my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.